Now let's see this question. This question came in GATE 2015 for 1 mark. The question is, the height of a tree is the length of the longest root to leaf path. Okay. The maximum and minimum number of nodes in a binary tree of height 5 is what? That we have to find out. Okay, so they are talking about height of the tree. So if a tree is something like this, then the height of the tree is, they are talking about the longest root to leaf path. So root to a leaf. What are the leaves here? Here, this is one leaf, this is one leaf. The longest root to leaf path. So here, root to leaf, the path length is 1. Here, the path length is 1 and 2. So they are talking about the longest root to leaf path. Longest root to leaf path in this case is 2. That's why the height is 2. That is the definition of height they are giving. Now they are saying that the number of nodes in a binary tree of height 5 is what? Okay. So firstly, let's try to go to the different extremes. What can happen? Let's firstly consider a let's say for a smaller case, let's say height, consider height 3. For height 3, what can be the minimum and maximum number of nodes? Okay, so what is the definition of binary tree? Binary tree is a data structure where tree data structure where each of the nodes can have maximum 2 children, at most 2 children. At most means it can have one children also. Each node can have maximum 2 children, but it can have a single child also. It can have 2 children also. It can have no children also. So typically, technically, a single node is also a binary tree. Similarly, this is also a binary tree because this is having 0 children basically, and this is having 1 child. So basically here also the child number of children is basically less than or equal to 2. So it defines. This is also a binary tree. Okay. So but we have to maximize and minimize. It means that for 3 nodes, what is the maximum height which we can attain? So for 3 nodes we can have something like this. So technically this is also a binary tree, right? In that case, for 3 nodes the height is basically 2. See, from root till leaf the length is, longest length, which is the only length here, is basically 2. So here height is equal to 2. What is happening is that, see, if height is equal to 2, what is the number of nodes here? It is basically 3, which is basically h plus 1. Height is equal to 2, and then h plus 1 is the number of nodes. You can test it for other. So if height is 1, then the number of nodes is 1 plus 1, 2. If height is 3, the number of nodes is equal to, if height is equal to 3 here, number of nodes is equal to h plus 1. H plus 1, which is 4. So now we are understanding that how we are calculating this. So we have come up with one scenario where if we have to find the maximum minimum number of nodes, then for a particular height h, the minimum number of nodes will be h plus 1. Okay, what about maximum? So let's consider height 1. For height 1, this is the maximum number of nodes can happen. For height 2, see, for height 2 we can have something like this. Most number of nodes we have to fit in. So let's say if we don't have this, then we can have one more node and still it is going to have height 2. But if we add this, then also number of nodes is increasing, but height remains still 2. We cannot add any more nodes. Why? Because if we add any more nodes, let's say something like this, then its height is going to increase. Now its height is 3, not 2. So for a particular height, this full binary tree is going to be the data structure which is going to have maximum number of nodes. So here we are going to see a pattern that, see, 4 to 6, 1, 7. So for height 2, we are going to have 7 nodes. Maximum 7 nodes. It is basically 2 cube minus 1, right? And it can be written as 2 raised to the power h plus 1 minus 1. This is a general formula which we are getting. Here also, see, if height is equal to 1 and we apply this formula, then it is going to be 2 square minus 1, which is 3. And that is true. See, 3 nodes are there if height is equal to 1. That is the maximum number of nodes which can happen to a binary tree which is having height h. Okay, so we have got two formulas. One formula is this one, h plus 1. This is the minimum number of nodes for height h, and this is the formula for maximum number of nodes which a binary tree of height h can have. Okay, now they have given this 5. So for 5, what is going to be the minimum number of nodes? Minimum number of nodes is going to be h plus 1, which is going to be 5 plus 1, which is 6. And what is going to be the maximum number of nodes? Maximum number of nodes is determined by this formula, 2 raised to the power h plus 1. Now h is 5 here, so 2 to the power 6. H plus 1 is 6 minus 1, which is going to be 64 minus 1, which is going to be 63. Sorry, 63. Okay, so 63 is the maximum number of nodes and 6 is the minimum number of nodes. So maximum and minimum nodes they are asking. So 63 and 6 respectively is our answer. 63 and 6 respectively. So A is the answer.